All right. Hey, this is the last video. This is from Wednesday to Thursday before your test. And I feel like this one is kind of a catch-all of a lot of uh, basic math and geometry concepts. So we're going to start with the simplest one that I noticed people were having trouble with, which is find two consecutive whole numbers that the square root of 35 lies between. In other words, what two numbers does that lie between? That's all, but two whole numbers. So to know this, you've got to know your squares. Okay, your square numbers are like 1 times 1, 1, 2 times 2, 4, 3 times 3, 9, 4 times 4, 16, 25, 36, 6 times 6, 7 times 7 is 49, and we've hit it, okay? In other words, the square root of 36 is 6, and the square root of 25 is 5. So the square root of 35 is going to be between them because it's less than 36 and it's greater than 35. But look how close it is to 36. If I had to guess, I would say that the square root of 35 is probably something like 5.87. Ready? I'm going to guess that. I don't know what it is, but hey, I'm going to try to find out right now just because. Why not? Desmos is the greatest place. Here you go. Ready? What is the square root of 35? You don't need to do this. I'm just curious. Boom. Oh, wait. Sorry, I think backwards. I'm old school. Here we go. 5.91. Poop. I'm a little bit off, but I was close. Okay. Let me find our thing. There it is, right there. Okay. So I was wrong. It was 5.91. All right. It was close though. All right. I like to guess. It's kind of fun. So anyway, the answer is simply this: 5 and 6. Moving on. Okay. The Pythagorean theorem should be definitely be a review at this point. The Pythagorean theorem is a squared plus b squared equals c squared. And the main thing you need to know is the Pythagorean theorem applies to only right triangles. Do not try to apply it to an obtuse or an acute triangle. No, don't do that. This is not right. Don't do it. This is not right. Don't do it. Okay? These are not right triangles. You can't do it. All right. A and B refer to the sides. It doesn't matter which side you call A, and it doesn't matter which side you call B. They're both just legs. That does absolutely matter. C must be the hypotenuse. Okay? That is the trick. So in this case, again, formula, substitution, and resolution. So here's the formula. Now substitute in 8 squared, 15 squared, x squared. 64 plus 225, I believe, equals x squared. Hello. Oh, let's try to write a nice equal sign so that I don't look like I wrote some weird symbol. X is x squared. Okay, x squared is equal to 9,689. Is that correct? No. That's not correct. Silly me. Stop trying to do that. Okay, 5 plus 4 is 9, 6 plus 2 is 8, and then there's a 2, 289. And then you would try to take the square root to get x by itself. You would take the square root of both sides. I want to say that's 17. 289. Oh, crap. Keep doing it this way. Let's try this again. Square root of 289. 17? Indeed it is. X is equal to 17. And that's the answer. Again, here we go. Different color. Okay. Find the side length x. Okay, again, a squared plus b squared equals c squared. Start with the formula. 16 squared. Couldn't read that. For a second there, I was like, what was that number? X squared equals 20 squared. Okay, 16 squared. You're wondering what I'm doing over there. I don't know what I'm doing over there. I know what I'm doing. I'm going to write 400. 20 squared is 400. X squared is x squared. 16 squared is 256. So, oh my gosh, this is what happens when I start working really fast. I start writing weird stuff on my paper. Okay, subtract 256 from both sides. X squared equals 4, 10 minus 5, no, 9 minus 5 is 4. 3 minus 2 is 1. And then x, take the square root of that, and that is 12. Okay. By the way, knowing your basic math skills are really helpful to get really fast. It's faster than a calculator most of the time for some of these simpler stuff. All right, here's a kite. A kite flying in the air has 12-foot line attached. Sometimes with these word problems, you have to kind of like read them, look at the picture, refer, try to figure out what the heck. Okay, so it's a 12-foot line and it's being pulled. Okay, and it casts an 11-foot shadow. Find the height of the kite. That's all we're looking for. So let's do it. All right, again, formula. Since it's a right triangle, we know we can use the Pythagorean theorem. We're going to go 11 squared plus b squared, which is going to be the height, is equal to 12 squared. This is 121 plus b squared equals 144. Subtract 121 from both sides. 4 minus 1 is 3, 2, 23. So b is equal to, and it says, if necessary, round your answer to the nearest tenth. So what is the square root? Dude. Wait, it says recording an extension cab. Okay, I don't know if this is working, but I'm just going to do it really quick. The square root, now I forgot what it was because Screencastify got me all flustered. 23. Okay, 23. What is the square root of 23? Let's try to get in there. Square root 23, 4.79583. Who cares? Let's see. 4.79. This is the tenths place. We're going to round it up. So it is approximately equal to 5.0. Because, I mean, God, I'm sorry. My brain is like fried. What I'm doing. I hope you're catching me before I'm catching myself. Okay, I was thinking whole number. I don't know what the heck is going on. So 9 is greater. It's going to mark that up to 8, 4.8. And whenever they say whatever place they say, you need to always make sure that's the last number that you put. All right, moving on. These are similar figures. And on similar figures, you need to just create a proportion because they're proportional. As this increases, so does this. As this does, that does. So you can set up proportions. It's really nice whenever you have similar figures. It says find the length of PQ right here. Okay, you could literally pick any side. They're just trying to figure out if you can figure out which sides are similar. I'm going to pick, it doesn't matter, I'm going to pick this side. I'm going to put the small over the larger is equal to the small over the larger. It's really important that you keep the same things in the right spot. In other words, I didn't put small over larger and larger over small. It has to be in the same order. I could have put another one, like I could have put like 4 over 7 in the same triangle. Look, short, long. That's equal to short, long. As long as you're comparing the same parts. All right, so now you got to cross multiply. You got a proportion. I'm going to switch colors because why not? 7 times 5.6. Oh, hush. 7 times 5.6. I don't know if you guys can see the calculator anymore, but whatever, 39.2. And then we are going to divide by 4. I'm just going to do this here because it's freaking me out when I go over to Desmos and it's like, gives me some weird message. 4 goes into 39. 9 times is 36. There's a 3, 2, 9.8. Okay. All right. And that's your answer. Moving on. Here's 6. Shen wants to measure the width of a river. Okay, so here's the river. Wow, that was really bad. Don't do that. Okay. Okay, the width of a river. He marks off the two right triangles as shown in the figure. The base of the larger triangle has a length of 56. Here it is. That's the base. And the base of the smaller has 34. The height of the smaller is 16.6. And how wide is the river? This is going to be it. There's your W. Okay, again, this is about similar figures and them being proportion. Okay, proportional, I should say. So you got to put the same things in the same thing. So you in the same location. So let's say we put the base of the large one over the height of the large and set that equal to the base of the small over the height of the small. Do you see how we're making these the right same, right? And we're comparing the same things. All right, the base of the small is 56. The base of the large is 56. Height of the large is question mark equals base of the small 34, height 16.6. And then you will cross multiply and solve. And I'm actually not going to do it, but I should see you solve this. Oh my God. You should solve this in your notes. Okay, finish it. All right. Hong caught a 5.5 pound fish. How much did it weigh in ounces? This is about conversion. And for that, you need to know the conversion factors. You need to know that in 1 pound, first of all, a pound is LB, which is weird. That is equal to 16 ounces. And if you don't know that, then this becomes a hard problem. Otherwise, it's not so hard. Okay, if he has 5.5 pounds of fish, we want to change that to ounces. So all we need to do is we know that for every pound, and we're going to change this to a simple fraction to multiply it. For every pound, okay, we have 16 ounces. And you guys, actually, let me do this in another color. Get over here, eraser. I want to show you something. This should bring back chemistry feels for you. You have 10.5 pounds, and in 1 pound, there are 16 ounces. Do you remember stoichiometry? Boom, boom, cancel your units, you end up with ounces. So this is you can easily simplify. 2 goes into 16 8 times, and the answer is 80 ounces. Okay, next. Again, here's another one. 62 cups of water, how much is this in gallons? For that, you need to know that in 1 gallon, I spelled that in Spanish, galón. Okay, here we go. In 1 gallon, how many cups are there? Okay, well, maybe you don't know that. Maybe you don't know, maybe you know that in 1 cup, in 1 quart, there's 4 cups. And in 1 gallon, there's 4 quarts. I don't know if you know this. If you know already that in 1 gallon, there's 16 cups, well then good for you. That's great. You can easily do this problem. Start with what they give you. Okay, we're going to change 62 cups of water, and we are going to change that to gallons. So we've got to get their inner conversions. Okay, we know that there's 4 cups in 1 quart, correct? This is like the conversion. Okay, conversion factor. You cancel your cups. Now we have quarts. Okay, I'll put that over 1. And then we know that there are 4 quarts in 1 gallon, and we have reached a gallon. Cancel the quarts, and look, we're left with gallons, and all you do is multiply across because you got fractions and multiply across. 62 times 1 over 16, okay? Which becomes 62 over 16. Let's divide by 2. We'll get 31 over 8. And then we'll get, how many times does 8 go into 31? It goes in there 3 times, which is 24 and 7/8. And that is your answer. And it says include the correct unit, gallons. Okay. Yep, that's it. It says write your answer as a whole number or a mixed number. Usually when they give you, like a lot of times when they work in these, they want to do that. They want to go back to mixed numbers. All right, a science fair poster is a rectangle 4 feet long. I immediately start drawing, you guys, no matter what. If they give me a rectangle, I draw it. What is the area of the poster in square inches? Okay, so this is 2 feet and this is 4 feet. Often in tests, you guys, they give you a lot of these where they'll give you them in feet and they're looking to see if you notice. Okay, so we should change this to inches. I'm just going to change it, redraw it so that I have room. I wouldn't have to. 2 feet. For this, you need to know that 1 foot is equal to 12 inches. So 2 times 12 is 24 inches. 4 times 12 is 48 inches. So it's going to be 24 times 48. And that is, I don't know, I'll go find out. $1,152. 1,152. What are your units? Inches squared. Moving on. Jane walks 3.5 kilometers every day. How far does she walk in 7 days? I've seen people actually do this, believe it or not, where they go Sunday, Monday, Tuesday, and then 3.5. Honestly, this is just a multiplication, okay? But they want you to change kilometers to meters. That's the trick. 3.5 times 7 is 35. 21, 22, 23, 24. 1 decimal over 24.5. But they want you to change it. This is kilometers. And they want you to go to meters. So for this conversion, you need to know that 1 kilometer, kilo, means 1,000, is equal to 1,000 meters. So you need to take this and multiply it by 1,000, which means you just move your decimal point over 1, 2, 3 places. And then that is the answer. 24,500 meters. Okay. A watermelon seed is 4. Here, we'll draw a watermelon seed. Okay. That's kind of like the shape of a watermelon seed, right? Okay, here we go. It's 4 millimeters long. How far would a line of watermelon seeds, of 120 watermelon seeds, stretch? Answer in meters. All right, so you're going to go 120, right? Because we have 120 seeds. You need to multiply that by 4. You're going to get 480. That's millimeters. For this conversion, milli also means 1,000. It's 1,000th. There are 1,000 in 1 meter, I should say. Sorry about that. Let's try that again. In 1, come on. In 1 meter, there are 1,000 millimeters. So that means if we have millimeters, okay, we need to get to meters, which means we're going to divide it by 1,000. If you were doing our little stoichiometry thing, you would put millimeters here because they would cancel. See? And you'd end up with 1 meter. Or you can just think it through. And that means you take the decimal point and you move it. Take the decimal point, you move it 3 spaces. 1, 2, 3. So the answer is 0.48 meters. So 120 watermelon seeds would only be about half a meter. It's not very long. Okay. It's a weird problem. All right, the 6 students in Mr. Bennett's class were asked how many minutes it takes them to get to school in the morning. And here's what they answered. All right, this is the mean and median of a data set. So in order to do, whenever you're given data, reorganize it in order. So it's 4, 4, always start with the lowest number, 1, 2, 3, 4s. And then you're going to go 10, 15. There's a bunch of people that live like apparently right outside of school, like on the other side of it, and a couple of people that have to walk. All right, find the median and mean, okay? Most of the time, people just need to be reminded what this is. I think median for me, the easiest way to remember that is when you're driving, those things that, you turn on when you go turn, like if this is the one way and this is the other way, and you pull into here to make a left turn, this is called a median. It's in the middle, okay? And that's what a median is. It's in the middle. So you start counting from the ends and you find the middle. So I've gone 1, 2, and it's 4. If you end up with an even number, a set of data points, you take the average between the two middle points. In this case, it's 4, and the mean means you add them all up and divide by the total. So 4 plus 4 plus 4 is 12, plus 10 is 22, plus 15 is 22 plus 15, 37. So the mean is 37 divided by 1, 2, 3, 4, 5. 5 numbers. Okay? And you could do this over here, or you could do it on a calculator. Oh man, it doesn't go in. Okay, how many times does it go to 37? It goes in there 7 times, which is 35. And you get 2, you add the decimal, add a 0. That was easy, 7.4. Okay, so the mean is 7.4. All right, that is it for your last day of notes on this unit.